So hello everyone, welcome to this channel again. In this video, let me explain about the exception in ARM version 7 architecture. So if you go through the crash issues during your project, I think that you may go through the tough time because you have to fix the crash issues as soon as possible. So when you bring up target device, so maybe your manager will be standing next to you asking a question like this: when can you fix the crash issues? In this case, the VSP engineers are under tremendous stress because we have to deal with this kind of problem as quickly as possible. But if you understand the mechanism of exception in ARM version 7 architecture, I think that you will receive the less stress. Then you can fix the crash issues and as quickly as possible. I think that you can resolve the issues. So in this video, I'm going to let you know the mechanism of exception in ARM version 7 architecture. So now I'm looking at is ARM reference document. The title of this document is ARM architecture reference manual, ARM version 7a, ARM version 7 ARM version. So as I told you before, this document is very huge, and the total page of this reference document is up to more than 2,000 pages. So if you're new to ARM version 7 architecture, you can just review the chapter of A2, application level programmer model. So application level programmer model chapter include the fundamental feature of ARM version 7 architecture. So as you can see in the document, the last contents of this chapter is exception, debug event, and check. Let me click. And the exception, debug event, checks are, this chapter is up here. And then here you can see the exception handling on page B1. And then let me click. So this chapter is B18 exception handling, and this chapter describes or specify how the ARM core handle exception, and then it specify the type of exception in ARM version 7 architecture. So there are several sections in this chapter, but I think that if you understand all of this chapter, one thing you have to remember is to understand exception vector table. So in this video, I'm going to show you how to understand exception vector table in ARM version 7 architecture. So let me click. Then, so you can see the exception vector and exception base address. Then, so you can read this content, but let me explain the most important part of this subchapter. This one is most important. So let me explain about this vector table. So ARM version 7 architecture define the set of exception, that is undefined instruction, supervisor call, pre-patch abort, data abort, IRQ interrupt, FIQ interrupt. Then I can say that there are two types of exception in ARM version 7 architecture. The first type of exception is memory overtime exception, where data abort or pre-patch abort are included as memory abort exception. Another type of exception is interrupt exception. So based on ARM version 7 architecture, the interrupt is handled as the one type of exception in ARM version 7 architecture. So meaning that if the peripheral device triggered interrupt, ARM core detected as the exception. So if you take a look at the exception vector table, there are Hive, monitor, secure, non-secure. I think that if you are first analyze this exception vector table, I think that you might be very confused to see the all of the item in the exception vector table. But if you are new to the exception vector table, I think the first step to learn the exception vector table is to understand this one, non-secure exception vector table, because the monitor secure that this type of exception vector is available, is effective only for trust zone feature. So without enabling the trust zone feature, so you don't have to analyze this type of exception vector. Hive type of exception vector table is varied when the system is running based on virtualization feature. So when the virtualization feature is enabled, the multiple operating system is concurrently running with the support of hypervisor. So hypervisor in ARM version 7 architecture is running at Hive mode. So I think that you are new to ARM version 7 architecture. The first things you should understand is to understand non-secure exception vector table. Okay, so let me pay attention to this exception vector table. So and another thing you have to keep in mind is the offset. Offset is 0, 4, 8, C, so 1, 0, and 1, 4, 1, 1, 8. In all this offset is seen as hexadecimal format. So in order to understand the exception vector table, you should be aware of the two things. The first one is when the target is booting up. At the initial stage of booting of the target device, the exception vector base address is specified. Exception vector base address is mainly stored into VVAR system register. Let me show you. Let me show you right now. That is VVAR. The VVAR register is holding or entry address of exception vector table. And then another concept is when the exception is triggered, and program counter of ARM core will branch into specified address, so based on offset value. So in case of undefined instruction exception, let me explain it. Let me copy and this one. Then let me copy offset the value of undefined instruction. So when undefined instruction exception occurred, the ARM core will branch into this address. So if the VVAR holdings this address, the ARM core will branch into the address based on this calculation by adding this one and this one. So exception vector address for undefined instruction exception could be this one. So please be aware of the fact that whenever exception occurred, the program counter of the core will branch to the specified address. That address is determined by this rule. Add the two value. The first value is exception vector base address, where this system register used to store the exception vector entry address, and then offset value can be added. So you should remember this rule. Okay, so another exception can be applied to this rule. So as for pre-patch abort exception, that each offset is C. let me copy. The offset is C. So upon pre-patch abort, the ARM core will branch into this address because offset is this value. So if you are new to the mechanism of exception handling in ARM version 7 architecture, I think that it is hard for you to understand this concept. But if you set up the breakpoint at this address, and if you identify that, yeah, breakpoint is break at the breakpoint, and you can see that ARM core will stop execution at breakpoint, and you will realize that this kind of operation, because when the exception occurs and this kind of operation is taking place from hardware point of view. So that's the main reason why you cannot see any kind of source code in assembly language to see this kind of operation. So in this video, I introduced the concept of exception vector table, exception handling in ARM version 7 architecture. So most key point of understanding exception vector table is to review the non-secure exception. So you don't have to analyze all other items like monitor, secure, hive. The first thing you should understand is the mechanism of exception in non-secure world. So thanks for watching this video. See you next time.